Good day, everybody. Hope you're doing great today. So here we go. The percentage of couple where both parties are in the labor force is 52.1. 5 couples are chosen at random. Part A determine the probability that none of the couples have both parties working. So first, we have to realize that this is a binomial probability problem. So binomial probability. Why is the question? Because two outcomes. Whenever there are two outcomes possible, it will be a situation for binomial probability. Okay? What are the two outcomes possible? Both parties working, or both parties working of the couple, or two, both parties not working. Parties not working. Okay? And given to us the information n, sample size, in binomial they call it number of trials. So number of trials is equal to 5, and p, probability of success, which is both parties working, is 52.1%, but we convert it to a decimal, which is 0.521. Please do not leave right away, because I will promise you I'll give you some important hint or tip at the end of this program. So let's create some space. None of the couples is working. That is the first part. So part A, none of the parties are working. So X is 0. So basically we have been asked to find probability of 0. So the formula for binomial probability is let me correct that, is NCX small p, probability of success raised to the power of x, and 1 minus p, probability of failure raised to the power of n minus x. So in our case, n is 5, c is 0. That is the number of ways that you can select 0 couple out of 5. 0 couple means none is working, to be multiplied by probability of success, which is 0.521 raised to the power of 0, because x is 0 in this case, and 1 minus 0.521, which is the probability of failure. That is to be raised to the power of n is 5 minus 0. So if I create a little bit more space, I get this as 5C0. Again, this is a combination, a number of ways in which you can select 0 couple out of 5 without regard to order, to be multiplied by anything raised to the power of 0 is 1, and then we have 1 minus 0.521. 1 minus 0.521. Remember, that's the probability of failure is 0.479, and that is raised to the power of 5. Now, in our calculator, there is a key, okay, which is 5 TI-84. Then I press the math button. Then I highlight PROB on the top. Then select or go down to NCR, okay, and hit enter. So I'm just calculating 5C0. and that will be equal to 5C0 will be, after we hit NCR, we will see 5C and then there is a empty square at the bottom of C. So there I will type 0 and hit enter, and that will be equal to 1. Hence, P of 0 is 5C0 itself is 1 multiplied by 1 multiplied by 0.479 exponented to the power of 5. And that in your calculator, you can type 0.479, then hit the exponent key. So you type 0.479, then this is your exponent key, okay? So hit the exponent key, then on top you type 5. This will put a exponent 5 over here and enter. And so P of 0 is equal to 0.479 exponented to 5 is 0.025. What does it mean? 2.5% chance of finding zero couple out of 5 working couple, out of 5 working couples. Okay, so that is your answer for the first part, where none of the parties are working out of 5 selected couples. Okay, so let's move up and take a look at part B. Part B says find the probability that at most one out of the couples have both parties working. That means out of n equal to 5 at most. Okay, so let's do part B. So part B is at most 1. At most 1 means you have to include x equal to 0 or x equal to 1. So probability of at most 1 is x less equal to 1 will be probability of x is 0, which we have already found out, plus probability of 1. Okay, at most 1 can include 0 and 1. We add the corresponding probabilities because these are independent events. Now we need to find out x of 1. So using the same formula, Px equal to 1 will be 5C1. Then probability of success is 0.521. That is raised to the power of number of success is 1. And then multiplied by probability of failure is 0.479. Then exponent 5 minus 1. So in our calculator, first we find out what is 5, then math, then PROB, then you select NCR and 5C1. So in the parenthesis or in the square in the bottom of C, you hit or you type in number 1 and calculate it. So 5 math, highlight PROB, then go down to NCR, enter, and then 1, and hit it is equal to 5. So it is 5 multiplied by 0.521 multiplied by 0.479 exponented to 4. And that is P of 1, which is equal to 5 multiplied by 0.521 multiplied by, in parenthesis, 0.479, close the parenthesis, exponented to 4, and hit enter. And the answer is 0.1371. So Px less equal to 1, which is at most 1. Okay. Probability of at most 1 is probability of 0 plus probability of 1, which is equal to 0.025 plus 0.1371, and that is equal to 0.025 plus 0.1371 is equal to 0.1621. So let me highlight that that is the probability of at most 1. Okay. Now let's move up a little bit. Please do not quit. I will give you an important tip at the end of this program. Okay, definitely. Okay. Now part C, find the probability that at least 2. At least 2 means 2 and above. Okay. So part C is probable at least 2. At least 2 means x equal to 2 or x equal to 3 or x equal to 4 or x equal to 5. Okay, so we have to find out probability of 2 plus probability of 3 plus probability of 4 plus probability of 5. This is at least 2. Now we have to think about the complement event of at least 2. What is the opposite or complement of at least 2? That is, what are the numbers we did not include in at least 2? These are 0 and 1. So we will use the probability law of complement event. Ability law of complement events. So probability of at least 2 or let me correct it saying at least 2 is complement of or opposite of complement of at most 1. Hence probability of at least 2 is, or probability of x greater equal to 2 is 1 minus the probability of complement event, which is x less equal to 1. So here we used probability of A complement, or complement of A is 1 minus probability of A. So my complement event is at least 2, and that is equal to 1 minus probability of A. A in this case is at most 1. Okay. So probability of x greater equal to 2 in this case we have already found in part B. What is probability of at most 1 is 1 minus 0.1621, and that is equal to 0.8379. So that's your answer for at least 2. Let me highlight that. Okay. So let me give you some hint at what we did. So basically, first we found out what is the first part was none of the couples selected have both parties working. That means x equal to 0. We use the formula for binomial probability, okay, which is uh, NCX multiplied by probability of success to the power of x times 1 minus probability of success raised to the power of n minus x. Since in our case x is 0, n is 5, it's 5c0 times 0.521 raised to the power of 0. Anything raised to the power of 0 is 1 multiplied by probability of failure, which is 0.479, and that is raised to the power of 5. That gave me the probability of out of 5, none of the parties have both parties working, which worked out to 0.025. So 2.5% chance of finding 0 couples out of 5 working couples who are not, none of the parties are working, okay? Now, the next was at most 1. You have to think at most 1 means 0 has to be included too, 0 and 1, okay? So you've already found out the probability of x equal to 0. Now you find the probability of x equal to 1 using the binomial probability formula, and it's 0.1371. Add it to part A. The answer is 0.1621. Next, they're asking at least 2. That means 2 and above. You have to think of the complement event of 2 and above. What is the opposite of that? That is 0 and 1. Then we use the law of probability of complement events. So probability of complement event is 1 minus probability of the other event. In this case, probability of x greater or equal to 2 is 1 minus probability of x less equal to 1, which we found in part B, and that is 0.1621. So hence the probability of x at least 2 is 1 minus 0.1621 is 0.8379. I'll stop here today. If you like this video, please give me a hearty thumbs up. I appreciate that, and that motivates me when I see those thumbs up, that I'm able to teach you, I'm able to show you how to do these problems. So also write me a small comment that you like this video. That also motivates me. And if you like this video, share with your friends. If you like this video, you and your friends subscribe to my channel, Math Science Topia, by hitting the red subscribe button at the bottom right corner. Okay. And please select the option that YouTube will notify you every time I upload a new video, which I do almost every day. So I'll stop here today. Thanks for watching. Have a nice day. Take care. And I will see you tomorrow. See you. Have a nice day.